Hello and welcome again, everyone. I'm Ayman Abdelwahed from Erasmus Rotterdam University, and in this video, I will be interviewing Roland van der Heijden from the municipality of the city of Rotterdam. Roland is the program manager for the Research and Development program of the Digital City of Rotterdam. He has a very wide experience in city planning, and he has strong interest in digitalization and how cities develop as a social, physical, and also digital construct over time. So I'm looking forward to this, and I'm sure that you will enjoy the interview with Roland. So let's start. Okay, so Roland, we are very happy and glad to have you here today as an expert in the field of digital cities and digitalization of the cities, and also with a big experience from the city of Rotterdam. We would like to welcome you, and I would like to start my questions with asking you a very general question, actually. What does it mean to create a digital city?
Thank you, Ayman, for the opportunity to talk about our digital city program. For us, it really means that you recognize that the city as a whole, the city as what we look like, as we know it for centuries, is really changing in its definition. We see that it's all changing from what we call a social physical city, in which we people and our physical surroundings create the city, as you call it, is changing to a social physical digital city. And that change, that we are changing from a social physical digital city, that means that all the problems and challenges that we as a city face are also changing. So when you look to a social physical glass towards climate change or towards energy transition, then you come up with other answers than when you look to the glasses of a social physical digital angle at this kind of issues. And also digital world as a whole also brings new challenges and opportunities with them. So the whole object that we are working on, the city as a whole, is changing by by adding that of recognizing that the digital world is a world on itself.
Takes me to the next question. So, what is actually digital twin in that sense, and why is it needed? So, if we define a digital twin to someone who doesn't really know anything about it, what is it?
In the most pure sense, in our opinion, it's nothing more, nothing less than a shareable, common picture of reality, mainly physical reality, described in terms of data. So we use the digital world, we use the data to describe the physical world outside, as it is right now, as you see it. And that we see as a basis for all kind of smart solutions that you can create on top of it, but also as a basis to work together. Because now every party in the city look at the environment again, sustainability, for instance. A lot of parties are involved, housing corporations, electrical companies, etc., etc. And now they all create their own policy based on their own reality that they use as a basis for their policy making. And then the answers that come out of the policy making are compared to what all the other organizations are doing, and it doesn't match. And it gives all kinds of discussions, and it gives a lot of issues. And a large part of those issues are not solvable because all those parts are also right, because they start from their own truth, and from there they are right for themselves. But it doesn't add up. So it's very important that we start with all those involved parties that for around a certain topic, that we start with the question, and the digital twin can help in that. Do we look at the same reality? Do we see the same world outside? Or what do you see and what do I see? And when we bring that together, then can we then create a common truth about what we are seeing outside? And when we have created that, then we can start building our policy making. And then when the answers from the policy making don't add up, then you have a much clearer discussion about why is your answer different from mine, because we started from the same reality. So you get a completely different discussion. And of course, that basis is also, as I mentioned in the beginning, a basis for all kinds of smart applications that you can develop. And those applications can also work together. Because for the applications, the same story is happening as for the stakeholders. Applications are also mainly silo-based developed, with their own truth put underneath that particular application. And also those answers are always right compared to another application, because they're both using their own basis to start from. So when we really want to go to a digital ecosystem in which people and applications can talk to each other based on the things they are doing, saying, thinking, then we need to create something that we have what you could call a sort of common language in which we can talk to each other. So we need something in which applications can create scenarios, for example, for climate change, and that they can bring the answers back to the digital twin, where they can use with other applications to do their part of the job. So, and to create that, that's really why a digital twin is very important, because a digital twin makes this all possible. That and applications and all the parties involved in the ecosystem can talk to each other, exchange data with each other, and use the results of each other.
Yeah, so we can say it is like a simulation plus a decision support in a sense, yeah.
In my opinion, it isn't simulation, it is the basis for simulation. But that's something different, because a simulation is always from a particular angle, because you want to simulate the climate change or the energy transition or the mobility, or so you're always simulating a part of what's happening, and from there you have your scenarios. But there's always your view of reality, your part of reality, and another one has another part of reality. But we want to all use the same reality, as a basis. And so digital twin is mainly the main goal is to go across all those silos instead of being part of one very beautiful but still thematic bound kind of a scenario or analysis, or what kind of smartness you can use your digital twin for.
Yeah, and I also guess this would allow like for a risk-free environment which we can try different things, and like make mistakes basically. It gives us the space.
Of course, when we have that reality, you can play with it. Of course, that's one of the big advances of digital.
Yeah, true.
But it's a basis for and not a part of. So that's important distinction.
Yeah, then actually maybe one question that come with anyone will ask at this moment. It's how would the integration take place? Because now, like, we have these two realities, and then how we can how the relation and how they impact each other, the digital and the physical reality.
Now, yeah, for us, in the context of the digital twin, as we now see it, where we start with, the digital twin contains, you could say, two major fundamental parts. And one of them is the whole 3D geo description of the physical world as we see it outside. The buildings, the trees, the benches, the lampposts, the garbage cans, etc. All the things that you can see outside are also modeled in the 3D world. So that's one part, big part, the description of the digital description of the physical world as we see it. And we combine that with all kinds of real-time data, mainly sensor data, about what's happening in the city outside. So the geographical data deliver the description of the physical world, and those sensor data, IoT data, are delivering the functioning of that world. So we have a garbage can, and we put a sensor in it, and it's telling us how full it is. Or we have a lamppost, and we put a sensor in it, and it's telling us if it's burning or not. Or a street, and how many cars are driving through, or what the air quality is. So when you bring those two things together, that's what we call a digital twin. Bringing those things together. But that's in terms of digital twin. When you really look to our lives, for example, where you see that digital and physical world completely already getting intertwined, but in the future it will be completely interwoven. It will be more or less one new dimension, you could call it, is by mobility. All roads are more and more not only a physical infrastructure, but also a digital infrastructure. And when we have self-driving cars, that physical and digital infrastructure is completely interwoven with each other. There's no distinction possible anymore between those two. Because all the signs aside the road must be digital, because the car needs them to be digital. We look at the physical sign of 50 kilometers is the limit, but when we have a self-driving car, we need to have digital information about that 50 kilometers is the limit. So I think that you cannot, for me, that's the most, the best example to show how everything will become, more or less completely interwoven with each other.
And how would that be maintained? Like when I hear that, how that would be maintained? Like it would be a big challenge to maintain this system, like, because then you need sensors everywhere, basically, I guess. And
Now, of course, you will have sensors there where you think you need to gather the data about that reality, because also on the other side, people who are interested in that part of reality. So it will be a process that's starting somewhere and will grow based on interaction between demand and supply. But it also, of course, means that we need to be smart about where we put sensors and why you put sensors. And for example, at this moment, it is still the case that we have 5-6 different parties all measuring their own air quality. Now, that's of course not very smart. You can measure once the air quality in a common sense, and then distribute it to that 5 users that use air quality. Another thing that we saw happening in our city, and that we now were able to change, is that what we call then the pole paradox, because we saw that a lot of departments within the municipality were all working on their own smart pole. So we had the division of communication who wanted the Wi-Fi poles in the city. And we had, of course, the Department of Lighting who wanted light poles in the streets. And we have the Department of Mobility that wants smart parking poles. And we have the Department of Sustainability that wants charging poles. And if they all put their own pole outside in the street, then it won't be very smart, because then you will end up on every meter you have a different pole. So it's very important to think about how you can combine these kind of things in one kind of smart pole that can be exploited in the sense that is needed at that moment. Okay, now we need a charging pole. Then we add up. Then we add the charging part to that pole that can be used for that usage. But at the same time, it can also be a lighting pole and an air measuring quality, or air quality measuring pole.
Yeah. So then actually, I think one question that is very related to our MOOC here. How can digital twins help in overcoming sustainability challenges in cities? Like, I think we already touched upon this a bit, but maybe if you have something more to add here.
Yeah, I think in the basis of the digital twin as a basis for better communication between parties in the city, and by building smart applications that we use with those parties in the city for all these sustainable challenges. And that's one of the important bases to get to better policy making. So that's one important part. And on the other hand, you can also use a digital twin as a basis for those smart applications. So also on the part of applications built on or using that digital twin, we can really help overcoming those sustainability challenges. For example, we are working on a tool in which we try to discover how we can use new digital means like techniques, but also 3D. 3D is not only the data set, but it's also a universal language in which you can communicate. Gamification principles, that kind of stuff. How we can use all those new digital possibilities to get into a better conversation with our citizens, so that they better understand what the challenges are, and how they can contribute to those challenges, how they can participate in finding solutions for it. So in that tool, for example, we build a 3D surroundings that's recognizable for the citizens, and then we start the same discussion. Do we see the same? Do we look at the same reality? Now the citizens says, no, in your model, my home has a flat roof, but look outside, my roof is really sloped. So, so that's the first start of the discussion. Do we look at the same? No, we don't look at the same reality. So that's the first start, and from there you can discuss. Okay, your roof is also okay. Your roof is sloped. We will adjust that, and then we can calculate the solar potential of that roof. Do you know what the solar potential is of your roof? That citizen says, I know what my solar potential is, but I don't know how far I am from the city district heating, and I don't know my energy savings potential. So I don't know should I use my solar potential, or should I go for city district heating or whatever. So he still is very confused in all the possibilities. So we really try to use this kind of new kind of tooling to really let the citizen better understand in what kind of situation he's in, what his possibilities are, how we can participate, how we can help him, etc.
But like in terms of energy sector, are there like any more thing we can discuss here?
Yeah, I think that because the digital twin is really in its optimum form, showing what's real time happening outside. And when you talk to the energy system, it becomes more and more important to find the balance between the supply of energy and the demand of energy, and the possible storage capacity of energy, to get the whole things even. You can imagine that the digital twin can be a part of that discussion in the real-time supply and demand processes and storage processes to all fit that together. Where at this moment the car is available which has a battery capacity to store or to charge what's necessary. You can imagine there. I think there's a lot of possibilities really directly connected to energy supply and demand, but also again to the process behind it. How do we work together in adjusting all the planning systems of all the different parties in the city about their networks? Because when we talk about energy systems, also about renewing our energy network, our physical distribution network. Do we do that alone, or do we do it together with district heating? That's also needs to be put there. And what is the water company doing? And when we adjust the plannings, it gives a lot of advantages. Big cost reduction, but also a much better service to our citizens again, so that not every 3 months the streets will be broken up, but only once, and then it's all put together. So yeah, I think there are a lot of possibilities there.
Actually, I have one question before going to our last question about Rotterdam. And my question here is about like the computational capacities that you need for this, because simulating all of this is not easy, I believe, or I guess. So what kind of computational capacities that you need to like simulate one city like Rotterdam, like with all of these entities and organizations playing around together?
Yeah, when you wouldn't when you have the full capacity on one place, then I think we need to wait for the quantum computer. But at this moment, of course, all this kind of calculations can be distributed in the network. So when we everyone who has his own application in which he wants to do something smart can use his own computational capacity. And so we don't do all those things at the same place. So everyone is doing his own calculation in its own place, and we're offering the basis. And from there, it's a network that where everybody can take part a bit of the calculation there. That's at this moment how it works.
Yeah. And my last question here is about the city of Rotterdam. I think we would like to know what is the timeline, and when do we expect to have this, let's say, initial version of the digital city of Rotterdam live?
Yeah. The end goal, as we see it at this moment, it's not a digital twin. The digital twin is for us the first step towards what we call a digital urban community. And when you talk about the social, physical, digital realities connected, then is a digital twin is mainly focused at the digital physical connection. But when we also make the connection to the social world, and all three realities are connected together, intertwined with each other, then we talk about the development towards a digital urban community. So that's what we see at this moment as some kind of end goal. It will never end, but it's sort of a momentary end goal, you could call it. And that we see happening within 5 up until 10 years. Before that, of course, now our first goal is working on the digital twin. Now, and at this moment, we are at the brink of the development of that digital twin. We hope that we can go live within approximately 1 year from now. And then people can see the first, it will be in a minimal form, but the first shape of a real digital twin operating in the city. And from there, it will be built further, scaled up, etc., etc. And the program that I'm the program manager for, the Digital City program, runs up until 2024. Now we hope by the end of 2022 to deliver our first form of a digital twin. So in the last 2 years of the program, we will scale up and add all kinds of applications to that platform with digital twin. And then, of course, in that 3 years, we hope that it will really thrive and become a very vibrant community using the digital twin, of course. And really, that the digital twin is really stimulating our local digital ecosystem, and it's really benefiting all those new companies working in the field of digital. Yeah, that's what we're aiming for.